Assalamualaikum warahmatullahi wabarakatuh and greetings. My name is Ahmad Fiman bin Makhni. I want to present my final year project entitled Efficiency of Fabrication Process by Reducing Working Time, a case study at fabrication workshop. First, introduction. The fabrication process involves process like bending, cutting, and measuring consumes a lot of times. Moreover, factors such as number of parts and processes, lack of skills, and the layout of the fabrication lab will determine how long the working time of the project. So, case study is done to analyze the fabrication process to find out the cost of the time consuming, and improvement will be made to increase efficiency. This case study is conducted at fabrication workshop at FKP 10. For the limitation of this case study, the time taken for the fabrication process might vary in large number because the fabrication process is done by different students. These are the problem statement in this case study. First, the time taken depends on the size and the shape of the product that need to be fabricated. Second, the layout of the machines and working tables can produce unnecessary motions can increase the process time. And third, the lack of student skills also affecting the duration of the fabrication process. And also the finishing quality will be affected too. Next, the objective for this case study. First, to investigate the current fabrication process by observing how the student fabricate the project. Second, to analyze and optimize the common working time on each fabrication process. And third one, to propose standard operating procedure (SOP) for the fabrication process. These are some literature review on how to improve efficiency of process. First, Jan 2016 stated that time studies are used to analyze the effectiveness of the applied resources for any organization in the current situation, and to determine what and where the losses happening for every factor. Second, Zuba 2015 stated that the purpose of each diagram is to analyze and find causes occurred and then to eliminate the mistake and apply measures that will prevent the reoccurrence of the mistake. Third, the need of standardization of work came from several aspects, such as variability of manufacturing process and inexistence of a detailed sequence of work procedures. This was stated by Braganca and Costa 2015. And last one, Amumala stated that by applying circular manufacturing system, a factory can reduce cost and improve quality and time. Next, this is the flowchart of methodology for this case study. The methodology consists of three phases, which are investigate, analyze, and propose. These phases are based on the objective of this project. For investigate, there are 4 steps. First, observation. There are several things that need to be observed during the fabrication project. First, product size and complexity to fabricate. Second, main process flow to fabricate the project. Third, student skills and performance conducting the fabrication process. Fourth, layout of work tables and machine at fabrication workshops. Next step is elemental breakdown. The main process flow for fabrication project is divided into work elements. Then, preparation. This is to prepare time measurement form and then to choose and define the student to be collected its working time. Next, data collection. This step is to observe and measure time of the fabrication process. For analyze and optimize phase, there are 4 steps. First, data collection. During this step, time study method is used to find the normal time and standard time for the fabrication process. The performance of students is rated using Westinghouse rating system first before calculating the normal time. Then, allowance time is identified before calculating the standard time. These are the equations involved during the time study. Second step is data check. Statistical process control (SPC) is applied to test the uniformity of the measured time by using X-bar R chart. The SPC is done using Minitab software. Third, Ishikawa diagram is used to find the root causes of unnecessary time consuming based on the unusual variation from SPC and problems occurred during fabrication process. These causes is categorized into 4M, man, method, machine, and materials in fishbone diagram. Fourth, method study is applied to categorize each wood elements and find the distance traveled in the process. Value added and non-value added are identified during this step. In this proposed phase, there are three methods applied to improve the efficiency of fabrication process. First, standardized work is applied to generate best work practices for each main process. It is also used as a guidance for conducting the fabrication project and to reduce reworks and mistakes. Second, relayout is implemented to reduce working distance and minimize non-value added process. Group technology is a layout that consists all the process for the same part in one cell. So, group technology is applied to relay out the fabrication workshop. Third, Kaizen is applied to suggest activity that will improve the efficiency of the fabrication process. The Kaizen activity is to minimize the problem based on the Ishikawa diagram. Next, let's move on to results and discussion. The result and discussion is based on the objective of this project. First, the investigate phase results. Based on observation, there are three main process flow to fabricate the metal scoop, which is metal sheet preparation, fabricating handle, and fabricating body. The student need to complete the product in 5-hour session, which is equal to 10 hours. One session, there will be 4 students to perform the project. Next, this diagram shows the current layout of the fabrication workshop. It consists of 2 work tables, 4 anvils, 1 drilling table, 1 bending machine, and 1 shearing machine. After observation, the main process is broken down into works elements. First, metal sheet preparation consists of 5 works elements, which is the least number of works elements compared to other main process. This diagram shows the works elements for metal sheet preparation. Second, fabricating handle consists of 16 works elements, which is the highest number of work elements compared to other main process. Majority of the students complete the metal sheet preparation and fabricating handle in the first session. This diagram shows the flowchart for fabricating handle. Third, fabricating body, which is the last main process, consists of 14 works elements. Majority of students done this process at the second session of the fabrication project. This diagram shows the flowchart for fabricating body. Next, this is the data collection, which is the observation of each main process. This table shows the data collection for metal sheet preparation, and this one is for fabricating handle, and this one is for fabricating body. The total time for each main process for each student is varies in large number due to the performance of the students. Next is the results for analyze and optimize phase. In the time study, to analyze the measured working time, the performance of students are rated by using Westinghouse rating system to calculate the normal time. This table shows the normal time and the performance rating for each student. Based on this table, the average normal time for metal sheet preparation is 3,521 seconds. For fabricating handle, 2,479 seconds. And last one for fabricating body is 5,656 seconds. The normal times are varied as it is calculated based on the performance of each student. Then, to optimize the working time of the main process, standard time is calculated based on allowance time by using the calculation above. The allowance time is allocated for 1 hour for each session for the student to chat with friends, goes to toilet, and asking to the lab assistant. This table shows the standard time for each main process. The total standard time for the fabrication project is 14,780 seconds, which is equal to 4 hours 6 minutes and 20 seconds, which is under 5 hours and supposedly able to complete in one session. However, the student will eventually exceed the standard time because commonly their performance are varies due to low efforts and consistency. This standard time can be referenced to make sure the students always alert to the time to increase their performance. Next, the result for data uniformity test. The data collected for metal sheet preparation is uniform and does not exceed the control limits for X bar and R charts. After that, the data collected for fabricated handle also uniform and does not exceed the control limits for X bar and R charts. However, the data collected for fabricating body is not uniform and exceeds the control limits for S bar charts. From these charts, we can see that sample 3 is over the upper control limits. However, in the sample range, the data is uniform. The sample tree will be analyzed using Ishikawa diagram to find out where it exceeds the control limits. In this part shows the result for Ishikawa diagrams. This figure shows the root causes for working time exceeds control limits problems. And this table shows the contribution for each root causes. Based on this table shows that the highest contribution root causes are mainly from man and machines categories. Next, this figure shows the root causes for rework problem. This problem is occurred at several students after making mistakes during the fabrication process. From this table, the highest contribution root causes is from methods category. The skill of students also highly contribute in this problem. As for the last result for Ishikawa diagrams, this figure shows the root causes for low quality of fabricated product. This problem occurred at students after completing the fabrication project. Based on this table, it shows that the highest contribution root causes are from machine and methods categories. The student skills and mistakes also contribute into the problem. Uh, the defects also occurred because of students forgot the flow process, and also there is no standard work. Based on the analysis done in method study, the total working distance for metal sheet fabrication is 22.2 meters until 13 meters. For fabricating handle, 18.6 meters until 54.4 meters. And fabricating body is 23.5 meters until 42.6 meters. This table shows the number of value-added and non-value-added process for each main process. Fabricating handle has the longest working distance because it has the highest work elements. However, the longest working distance by comparing all the work elements is moving from bending machine to drilling table, which is element 16 of the fabricating body, which took 11 meters. The location of bending machine is quite far from the work table and the other machine. This generates unnecessary movement, which increases the working time. Based on the method study, the number of non-value-added process is higher than the value-added process because of the number of delay and transfer process is higher than the number of operation process. This is the method study for metal sheet preparation. This table shows the category for each work element and the distance traveled in each work elements. This diagram shows the shortest and the longest working distance for each work elements. This is the method study for fabricating handles. This diagram shows the movement of students during the fabricating handle process. This table shows the category of each work elements for fabricating handle and the distance for each work elements. And this is the method study for fabricating body. This diagram shows the working movement of the student during fabricating body, and this table shows the work elements categories and the distance travels in the work elements. Lastly, this is the result for proposed phase. First, standardized work chart (SWC). Current process flow is given orally during the briefing before starting the project. However, only several students list all the process flow. During the middle of the process, some students forget the process flow and starts making mistakes. Moreover, there is no detailed written process flow given in the lab sheet. Figure beside show the current process flow in the lab sheet. The current procedure is too general and not helping during the fabrication process. The SWC has the detailed work elements for each main process and sequence diagram to be used as guidance for the students to conduct the fabrication project. The SWC is targeted to make sure the fabrication process is done efficiently without making any unnecessary operation or movement and improve the quality of the product. This figure shows the SWC for metal sheet preparation. In this SWC, there are step-by-step process for the metal sheet preparation and the diagram for the movement of the students. Next, this is SWC for fabricating handle, and this one is SWC for fabricating body. Next is standard operation procedure, SOP. The SOP is applied at the work elements that students always making mistakes, such as during bending the sheet metal and during the drilling the holes, which contribute to low quality of product and reworks. The SOP has the step-by-step process flow and diagram to conduct the process to make sure that the student does not making mistakes again. The SOP should reduce the mistake and prevent the rework from happening. This is the SOP for work element number 15 of fabricating handle, which is bending the side part of the handle. Previously, students always making mistakes during bending the side part of the handle because they are confused which parts need to bend first. So this SOP will show them which part need to bend first and how. And this is the SOP for work element number 12 of fabricating body. Same as before, student always making mistake during bending the body. So this is the SOP to reduce the mistakes. This is the SOP for work element number 4 and 14 of fabricating body, which is drilling hole. Before this, student always confused which holes need to be drilled first. Because of that, after bending, the holes doesn't match and they need to drill the hole back. So this can contribute to the low quality of product. Next is layout. This figure shows the current layout for the fabrication workshop. As you can see, the bending machine is located far from the work tables and the anvils is located far from this work table. This can create unnecessary movement. So to reduce the working time and distance traveled, the bending machine is located beside the shearing machines and the anvils is located between the work tables. From this layout, the working time and distance traveled is reduced around 50% and above. As example, bending machine to anvil from 3.1 meters to 1.1 meters, and the working time is from 3 seconds to 1.2 seconds. Work table to bending machines from 9.8 meters to 4.1 meters, and next for working time 5.3 seconds to 2.2 seconds, and bending to drilling table from 11 meters to 5 meters, and working time from 6 seconds to 2.8 seconds. And the last part for proposed phase is Kaizen. In this part, simultaneous work is proposed to utilize the space on the machines. As you can see, for bending machine and shearing machines, there are some space for two students to perform cutting and bending together. This can reduce the waiting time. Usually in one work tables, the working time is almost similar because both of the students will wait each other when completing a process. For example, in sample 1 for metal sheet preparation, student B took 231 seconds for work element 4, which is cutting the metal sheet into 2 pieces using shearing machines. So the student B partner will wait 231 seconds to use the machine. To eliminate the waiting time, they both should use the machines simultaneously. And now let's move on to conclusion and recommendation. Based on this case study, time study is a method that can be applied to obtain the standard time so the student have a benchmark to conduct the fabrication project efficiently. Based on uniformity test, the observed time work for all samples are uniform, but there was one sample is out of control. This shows that the uniformity test using statistical process control can analyze the variation of the data and finding the data that out of the limits. Ishikawa diagram is useful to find the root causes for the problems that occurred during the fabrication project and also the data that are out of control based on the uniformity test. The root causes are analyzed to find the solution to reduce or eliminate the problems. Next, the application of method study was able to categorize of each work elements and measure the distance traveled by the students from machines to another. The method also can identify the value-added process and non-value-added process. For improvement, the SWC and SOP are great to use as guidance for the student to conduct the fabrication project. Next, the proposed layout also shows how the working distance can be minimized to reduce the working time. Lastly, the Kaizen activity, which is simultaneous work, should eliminate the waiting time to use the machines. For recommendation, in future study, the case study need to be detailed more on the time, like collecting the lead time, waiting time, and the working time for each work elements. And that's all from me. Thank you.